Okay, welcome to the Dublin Academy of Maths. Okay, now we're really rounding things up here, and I've committed myself to doing a few graphs here in this and trying to decipher them. Anyway, statistics, we're on series 11, episode 3, and it's paper 2, and we're in around question 6. Now the last day we had a stem and leaf cell here, stem and leaf diagram, and I included 183 times, which actually was 167 3 times. But not to worry, the method was correct, but the answer probably wasn't. Anyway, so today we're going to try and interpret graphs, okay, types of graphs. Now I have another video, or maybe another 2 videos after this, and it's all to do with interpretation of graphs, okay. Now let's start with this. Okay, so we have we want to find the median. Okay, so how do I find the median of this? Do you remember how to do it? So we cancelled them off, okay, and we found the middle term, okay, and we cancelled them off by going 9, 7. You know, we cancelled until we got to numbers. Okay, so this was 24 numbers, 24 elements, or 24 datas, as they call them in America, 24 pieces of data. Okay, so we found that well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it was 170. Now 170 plus 171 all over 2 is 170.5. Okay, so that was the median. Okay, so we cancel them off. Remember, we cancel them off. This is in the last question. Okay, going in chronological order, up and then back down in chronological order. Okay, so you got 3, you got there, and you just keep going on until you get to the 1, 0, 1 and 1. Okay, so you got 6, 6, 7, 5, 2, 8, 1. Okay, so we got 0, 1 and 0. 170 and 171. Okay, now the mode. The mode is the most common element. That means it appears the most, and it's, look at it, 1677. So your mode will be 167. Okay, it appears 3 times. The range now, okay, the range of values. Before we get to the range, I'd like to get the central tendency. Okay, the central tendency is here. Okay, is in that part there, and in that part you're going to find the mean and the mode and the median. Okay, let me put the mean up here, right, because they're related, and we'll get back to that in a minute. Now the range is the largest minus the smallest, so it's 187 minus 149. Okay, and the answer is whatever. Okay, well, it's 36. Okay, so that's the range. Yeah. The interquartile range. Now remember, the interquartile range is first of all we have to find Q1, which is the first quarter. Okay, so the first quarter of the sample size, and we know the sample size is a number of elements in there, and the number of elements was 12. So it's worked out as the third term, and then we added the fourth term divided by 2. Okay, but if the third term became a fraction, we just rounded down, always down, okay, to 9, and we rounded down to 9, and we use it, well, not in this case, but we use it as the first quartile. Okay, so we found our first quartile, and we put in our values on the third and the fourth. Okay, so they would go in there. Okay, so the third, 1, 2, 3, 160, so that's equal to 160 plus the fourth term, 1, 2, 3, 161. And we divided by 2, we got it's 160.5, and that's it. You leave it at that. You don't round down this. It's only when you find the third term that is a fraction that you round it down. Okay, so that was the Q1, and then we found Q3, and then when we found Q3 was the 3/4 of 12. It's the 3/4 or the 75% of 12, and that worked out 4,9. So it's the 9th term. Okay, so the 9th term was 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me do that again. 1, 2, 3, 4, 5, 6, 7, 9, and then we use it in 10, so it was 167. And there's no need to add 167 to 167 and then divide by 2, because we'll only get 167. Do you understand? Okay, so the answer was 167. So that's your, and then we took them away. So the interquartile range was the difference between 167 minus Q1. Okay, and we found that that was 7 centimeters. Okay. Right. So the that's good. So the standard deviation. No, when we did we do. So that was the interquartile range, and the interquartile range just gives you just what the median size sample is. So the mean size sample. Okay, so we've got standard deviation next. Standard deviation, also known as sigma. Okay, the mean is known as phi. Okay. Right, so we got the interquartile. Now the sample size. Now the sample size is very small here. This is good. The stem and leaf cells, the stem and leaf plot graph is good for small sample size. Okay, so small sample sizes for here. So you have small, usually from 10 to 120. Okay. The central tendency, as you know, is in and around here, and the mean is in here, and the mean, the median, as you can see, we've discovered them, and the most common element is in here. Okay, so the central tendency tends to tell us where all the activity is happening. Okay, now we have a few outsiders, and you always have outsiders on samples. Okay, now everybody follows the same path. Now, and we say we're moving along here. This is a normal distribution curve. Okay, a normal distribution curve. Now, in this normal distribution curve, this would be like a sample over here. All the mean lies between the mean lies in 70%. So the 70% of the sample lies within the mean, very close to the mean. Okay, and as you go further out, as we see here, as you go further out, you reduce. There's fewer samples that agree with the mean. Okay, in other words, they're outsiders, extreme points. But anyway, all you have to know is that the sigma is here, and this is plus 1 times sigma. Okay, which is the standard deviation. So we're moving across by standard deviation. So the standard deviation is 2. Okay, so you're moving across by 2. But any normal curve, any curve you will see with this shows a normal distribution. You can put in your point and you can say that's the standard deviation, and that's 34%, and that's 34%. This is taken as general verbatim. Okay, so this is 1 sigma and this is 2 sigma. So the whole sample size, 99% of it, lies within the range of minus 2 sigma to 2 sigma. Okay. Right, so that's where your sample, the mean sample, most of the sample size will occur is in there. Okay, I'm just going to refer to my notes. Now, the mean. So on this graph here, so if you look at the expression as percentage, it's expressed as percentage points. Now this is very important with finance. Okay. Now this can predict volatility, finance volatility, and in other words, how the markets are going if your standard deviation is going to go off skew. Okay, so this is a positive skew, right? As you can see, this is a positive skew. In other words, it's going up like that and it's going down. Okay, so it's on a slope as it's rising. Okay, so it's a positive skew. So this is normal. This sample size is usually is a huge sample size. Okay, usually population studies, right? Usually population studies. Right now, let's find out. So where would the mean lie? Well, the mean lies next to it. Okay, I'll show you another graph later, and the mode is going to be next to it as well. Okay, so they're all hanging around the same area. This is the central tendency area. Okay, all of that area. Anything else? Now let's go through them. So the mean, that's the mean. With the mean. Okay, if I was to find the mean of that, I would draw another line. I would draw 3 lines. One represents the mean and the other represents the mode. Okay. Now when they come up, this is mode. This is usually mode, then median, and then mean. Okay, now these are the 3 lines here. Okay, this is usually taken as standard. Now I'll do this again. Okay, let's look at this anyway. So we've done the mean, median. The median is the halfway point. Actually, this is the median here. Okay, on that point there, because it is the halfway point, as you can see. Now remember, the area underneath it represents the frequency. Okay, so this is the highest point. In other words, this occurs the most. Okay, so the mode will be on that as well. Anything else on this? No, there's nothing else really on that. I'm trying to look for something else now. Oh, empirical formula. Okay, so this is the empirical formula. Right, that's what I meant to get at. Good. So the empirical formula means that it lies between that. Okay. An empirical rule, all values in a normal distribution lie within three derivations, within three standard deviations. Okay, so they all lie within standard. Okay, there's another one out here, alright, yeah? And this is the third one, but this includes the really way outsiders. Okay, so the empirical rule will include all the way up to the third one. Okay, right, that was a bit of a mistake there. But anyway, all the way up to the third one. But most of them, as you can see, the percentages are given here. So if you were saying, would it be possible to say that 70% lies between 1 and -1 sigma and +1 sigma? And the answer would be right. Is it true that 99% of the sample size lies between -2 sigma and 2 sigma? Yes, correct. And you would make that because this is now taken as official. Okay? As officiated. Right, is there anything else here? Standard deviation indicates how much variation. Okay, so the standard deviation indicates the variation. Dispersion from the average exists. Variation or dispersion from a low. Okay, now if we have a low standard deviation, right, that means that we have a good spread. Low standard deviation, a good spread. That means that they are all spread around the mean. Around the mean. And you see that in scatter diagrams. Okay, so a low, so if you've got, it's usually, it works out around about 10% of the mean. Okay, is the value S. The standard deviation is usually around 10% of the mean, and if it's 10%, it means that it's a good sample. It's believable. It's trustable. Okay, and you can remember, right? So there's a lot of you know, you have to use your words economic here. We're going to do a few more questions, but anyway, I'm going to leave that with you for the moment. You can go over the video, maybe we can talk about it again later. But we'll be done with doing another few diagrams. Anyway, we'll leave it at that. Thank you very much.